What's up, space fans? Welcome back to SpaceX Central. I'm your host, bringing you the most cutting-edge of SpaceX analysis on YouTube. Today, we're diving into some absolutely mind-blowing new revelations. Fresh footage from Starship Flight 8 has just surfaced, and what we're seeing will shock you. We're talking never-before-seen angles of the catastrophic engine failure that destroyed Ship 34, captured in stunning detail that the public stream never showed us. But that's just the beginning. We're also exploring something even more exciting: SpaceX's revolutionary Raptor 4 engine that's about to redefine space propulsion forever. If you're new here, smash that subscribe button and hit the bell for notifications. Trust me, after today's deep dive, you'll understand why the next few years will be the most transformative period in spaceflight history. Let's jump in. As we approach the highly anticipated Flight 10, we need to understand what went catastrophically wrong during Flight 8. This wasn't just a spectacular failure, it was a masterclass in engineering lessons that are shaping Starship's future. Recently shared internal footage offers a completely different perspective on Ship 34's final moments. These behind-the-scenes images reveal details that are both fascinating and absolutely terrifying. Picture this: a Raptor engine violently torn apart, completely exploded and detached from the spacecraft. In this unprecedented photograph, the engine's nozzle is split clean down the middle. The upper section is completely shredded and exposed like a peeled banana. The protective outer shell is missing entirely, revealing intricate inner mechanisms never meant to be exposed to such devastating forces. Scattered fragments fill the frame, each piece telling the story of incredible violence. This isn't just an engine shutdown. This is complete structural destruction at the molecular level. Other newly surfaced images are equally dramatic. In one frame, two Raptor vacuum engines are completely engulfed in flames, looking like something from a science fiction disaster movie. In another, smoke and vapor blast outward from the sea-level engines like an industrial explosion. By cross-referencing these images with live stream footage, we can now construct a precise timeline of disaster. At approximately 7 minutes and 45 seconds into flight, fires and thick plumes first become visible within just 20 seconds. Imagine that, 20 seconds. The situation deteriorates so rapidly, it's almost unbelievable. By 8 minutes and 5 seconds, one vacuum engine and 3 sea-level Raptors have completely failed. Explosions erupt across the screen in a cascade of destruction. The loss of multiple engines throws off thrust balance so severely that loss of control becomes inevitable. Here's what makes this evidence particularly intriguing. The image showing the engine falling away from the spacecraft isn't found anywhere in public footage. This strongly suggests it was captured using internal SpaceX diagnostic cameras, giving us an unprecedented glimpse into the true severity of those critical moments. SpaceX's official analysis attributed the vehicle loss to hardware failure in one central sea-level Raptor engine. The failure allowed fuel and oxidizer to mix unintentionally, triggering the massive explosion we witnessed. The photographic evidence strongly supports this explanation. Picture this scenario: a deep crack probably formed in a critical structural area, perhaps between fuel lines or in a high-stress joint. This crack grew over time under immense operational stresses, forces and temperatures that would destroy conventional materials in seconds. When the structural threshold was reached, the crack widened catastrophically, causing sudden and complete rupture. The clean split visible in the engine nozzle suggests structural failure began well before final burnout. As the failing engine disintegrated, shrapnel and superheated gases likely damaged neighboring components, sparking a devastating chain reaction. In such high-stress, high-temperature environments, even a single compromised engine can wreak absolute havoc in mere moments. This is the reality of pushing rocket science boundaries. Sometimes the frontier pushes back. Despite Flight 8's severity, SpaceX demonstrated exactly why they lead the aerospace industry by acting with incredible speed and precision. For Flight 9, Raptor engines were upgraded with key improvements directly addressing Flight 8's failure modes. These enhancements included significantly stronger structural joints with increased preload, essentially making engines more resistant to crack propagation that doomed Ship 34. They implemented a new nitrogen purge system specifically designed to prevent unintentional propellant mixing that triggered the explosion. SpaceX also installed more efficient fuel drainage systems to reduce residual propellant risks during engine operation. These improvements built upon earlier adjustments after Flight 7, when harmonic vibrations caused premature engine shutdowns, while Flight 9's engine performance was dramatically more stable. That mission faced a completely different challenge, a propellant tank leak causing pressure drop that starved engines of fuel, eventually causing Ship 35 to lose control in a different failure mode. This illustrates the incredible complexity of SpaceX's mission. Each flight reveals new challenges, and each challenge drives innovation, making the entire system more robust. This brings us to one of the most exciting developments in modern aerospace engineering, the evolution of SpaceX's Raptor engine family. What we're witnessing isn't just incremental improvement, it's a complete revolution in rocket propulsion philosophy. For over a year, the space community eagerly awaited Raptor 3, but SpaceX has already begun teasing something even more revolutionary, Raptor 4. This represents the next quantum leap in propulsion technology. The sleek, black Raptor 3, unveiled last year, serves as the mechanical heart of Starship version 3. This larger, more capable Starship variant will stand nearly 150 meters tall, taller than a 40-story building, and is expected to debut within months. But here's where it gets really exciting. Hints about next-generation Raptor 4 first emerged during a fascinating interview between Elon Musk and everyday astronaut. Musk referenced an engine version capable of producing 330 tons of thrust, a figure that should make your jaw drop. For context, Raptor 3 delivers around 280 tons of thrust. A 330-ton version clearly represents something far more advanced, indicating introduction of a completely new engine generation that will redefine what's possible. Let's talk about what these numbers actually mean, because they're absolutely staggering. With planned output of 330 tons, Raptor 4 will be approximately 17% more powerful than Raptor 3's impressive 280 tons, compared to current Raptor 2 engines. We're looking at a mind-blowing 43% increase in thrust if SpaceX maintains current Starship architecture. Super heavy boosters equipped with Raptor 4 engines could generate up to 1,890 tons of liftoff thrust. That's more than triple the thrust of the legendary Saturn V rocket that took humans to the moon. Future configurations suggest Super Heavy could carry 35 engines, while the ship itself could hold 9 sea-level engines plus 3 vacuum variants. This setup could push total liftoff thrust past 11,500 tons, while the ship alone would exceed 3,000 tons of thrust, nearly rivaling Saturn V's total lift capability. Raw power is only part of the story. Perhaps even more impressive is SpaceX's revolutionary approach to engine design philosophy. Radical simplification, making these incredible performance gains possible. With Raptor 3, SpaceX made remarkable strides reducing complexity by integrating or eliminating many small, failure-prone components. Raptor 4 is expected to continue this trend, and the implications are profound. Simplified design doesn't just improve reliability, it makes manufacturing faster, more cost-effective, and enables rapid production SpaceX needs for ambitious mission schedules. By eliminating flanges and bolts, notorious sources of leaks and mechanical failures, SpaceX is moving towards seamless construction, relying heavily on advanced welding techniques. This creates stronger, leak-resistant joints while dramatically increasing overall reliability. The numbers tell an incredible progress story. Original Raptor 1 weighed about 2 tons. That reduced to 1.6 tons in Raptor 2. By Raptor 3 production, weight dropped to just 1.525 tons. When you apply this mass reduction across dozens of engines per rocket, you get significantly lighter launch vehicles, translating directly into dramatically improved performance and efficiency. So when will we actually see Raptor 4 in action based on SpaceX's broader mission schedule and development goals? Raptor 4's debut is likely still a few years away, perhaps not until 2028 or beyond. This timeline aligns with SpaceX's incredibly ambitious roadmap. By 2028, SpaceX expects to complete initial human landing missions under NASA's Artemis program. Following those landmark missions, the company will need significantly more capable Starship versions to transport larger crews and heavier cargo as they begin building sustainable lunar bases. That time frame perfectly aligns with Musk's Mars exploration vision. This will be the period when SpaceX begins installing first permanent systems on the Martian surface. Following successful demonstration missions, proving Starship's ability to reach and land on the red planet reliably. While we wait for Raptor 4, we can look forward to witnessing Raptor 3's remarkable performance. This new engine version is scheduled to launch later this year, likely around the time SpaceX attempts one of its most ambitious tasks yet, catching both Starship stages using Mechazilla arms for the first time in history. Following that milestone, focus will shift toward building and testing in-orbit refueling systems, directly tied to Starship version 3 design. After refueling systems are operational, SpaceX will deploy specialized lunar Starship variants for unmanned demonstration missions preparing for future crewed lunar landings. The most historic mission will be Starship's return of humans to the Moon, marking over 50 years since humanity last walked on the lunar surface. From Flight 8's dramatic engine explosion lessons to Raptor 4's revolutionary promise, SpaceX continues pushing aerospace engineering boundaries. The newly revealed Flight 8 footage reminds us that rocket science progress isn't always smooth, but every failure teaches us something crucial about the physics we're trying to master. Those exploded engine fragments aren't just debris, they're data points informing the design of engines like Raptor 4. Are you excited about upcoming Raptor engine evolution? Drop a 4 in the comments if you can't wait to see Raptor 4 in action. And let me know what aspect of this engine development excites you most. Don't forget to like this video if you found this analysis helpful, and subscribe to SpaceX Central for the most comprehensive coverage of humanity's journey to the stars. Hit that notification bell so you never miss our breaking SpaceX coverage. This has been your host reminding you to keep looking up toward the infinite possibilities awaiting us among the stars.